So we discussed about the def file, right? 1 second. So you're able to see the screen, right?
Yes, sir.
Yeah, cool. So we already discussed about the def file. Def stands for design exchange format, and def is nothing but like a location and entire physical information of a particular cell and macros and metal layers. Okay, we can say in a simple manner the location of every single thing. Okay, so diarrhea, tracks, site rows, macros, and standard cells. What are the ports in the design? What are the location of shapes of all nets? What are the blockages we have? Scan chain, NDRs, stacked wire definitions, all those things. Okay, so every single thing we are going to get from a def format. Okay, so in a def file we can see. Okay, I think I asked one question, right? Somebody get the answer. I said, did anybody give a try? Pandey?
Yes, I have tried, but
Couldn't.
yes.
Fine.
But one thing I want to tell that
Mhm.
you asked the question like we have to connect L1 and L3 without using.
Separate M2 layer.
Yes.
Mm.
So we can use another L3 layer and connect L1 and L2 through via hole.
Sorry, 1 second, Pandey. Let me connect the writing pad. So you're talking about 1 second. So we have M1 in this manner and M3 in this manner, right? Now tell me, Pandey, what you're trying to tell. Pandey, tell me, man.
Yes, previously you have drawn the M3 layer is just below the M.
Sorry, I didn't get you, Pandey. Repeat the thing, man.
Okay, yesterday you have drawn the M1 layer and below that M3 layer, and we have to connect.
This is how I drawn, huh?
No, parallelly, M1 and M3.
This is
Yes.
how.
Yes.
Oh,
yes.
sorry. Yeah, correct. So we need to connect this thing. I mean,
Yes.
in this way, I mean, I used M2. No,
Yes,
I didn't use
yes.
M. I used M2 also, right?
Yes. So you told you need we need to use M2.
No. This is fine. M1, M2, M3. This is fine. I asked you like, this is M1, this is M3, for example. Now we
Yes.
need to use M2, right? But I don't want M2. I want to connect M1 and M3. This is what I want. Between M1 and M1 and M3, I don't want M2. How can we connect? This is the question, right?
Right.
So how come? So I mean, you couldn't. Fine, that's okay. I will give the answer. So anybody, Satish,
No, sir, I couldn't get the answer.
did you try?
Try, sir, but not
What
getting,
is-
sir.
What are the thoughts? What are the thoughts you got? What are the try? I mean, what are the tries you did?
My any via is there for connecting.
You felt like to connect directly from M1 to M3, one via should be there, right? This is
Yes,
what you're trying to do.
Yes, sir.
Okay. So, Krisil, any try? I mean, at least did you give a try? How come M1 to M3?
Yeah, mine is same as Pandey's actually. Direct via.
Direct via. Oh, kind of M1 to M3 direct via you need, right?
Yeah. Hmm.
Fine. The thing is like via is fine, but the thing is like, see, for example, we use 2 by 2 via. So some of the via will be looking like, okay. For example, I'm just drawing that. This is like V1. V1 attaches the M1 and M2. Means M1, V1, M2. This is how layers will be looking like, okay. M1, V1, M2, V2, M3, V3, M4, V4, M5. This is how layers will be looking like in your tool, okay. So M1 and M2 will be attached by V1. Okay. So M2 and M3 will be attached by V2. So for example, this is like M1. Sorry. This is like V1. Sorry, this is like V1. Now you need V2 also to connect the thing, right? Now you are going to insert in this via V2. Again, one more via. Means via on top of one more via, which we call as stacked via. Means, for example, I am just telling M1 to M3 only because V1, V2 will be there. Okay, two different vias. Okay, but for example, I want M1 to M5. Okay, now here group of vias will be there, right? Means V1, V2, V3, V4, V5, right? All these vias will be placed at this place only. Okay, means here we have group of vias. Okay, this particular means adding a group of vias is called stacked via. Means stack means kind of list,
arrangement.
right? Yeah.
Yes, arrangement.
Yeah, the arrangement. So this is how one top of one more. Okay, this is how you are going to insert in this place M1 to M5. If you want to connect V1, V2, V3, V4, V4, all these vias will be placed here only. Okay, this is the thing. This is called stacked via. Means first V1 will be placed, on top of that V2 will be placed. So M1 to M3, the connection will be there because M1 to M2, the via is like a V1, right? So V1 will be containing M1 properties as well as M2 properties, right? So we are placing V2 again. V2 will be containing M2 properties as well as M3 properties, right? So if we connect M1 to M3 through V1 and V2, okay, then M1, M2 plus M2, M3, right? That is what I tried to ask you. Got the thing, everybody, or shall I explain one more time?
Got it, sir.
Cool. The thing is like we are placing one more via on top of one via. Okay, means we are putting in this kind. Okay, in a stack manner, one on one. Okay, this is called stacked via. Okay, so this is like very silly thing. I mean, if you see the thing, the real physical layout or kind of stuff, you will come to know. But first, you need to know this. This will be named as stacked via. This is the basic thing you need to know. Okay, that's why I'm just trying to tell you. So that's the thing. So Satish, got the thing right?
Sir, once again tell us, sir. M1 to M5.
One second. Okay. See, you understood, right? M1 to M3.
Yes, sir. And M1
The
to
same
M2.
way. The same way.
M1 to M3, sir.
M1 to M3. V1 and V2 will be there. Two vias we are going to place. Means
First
one
we
more than one
M1
via.
after M2, M3.
More than one via we call a stacked via. Okay. See, for
More
example,
than
you
one
have
via.
M1 and M5. Okay, these two belong to net underscore one only. Means net names are same. Okay. So if you select on this, give one right click and give add missing vias. I mean, in the tool, you will be seeing one option like add missing vias. Okay. If you can select either this piece or this piece. Okay. So click on this and give add missing vias. M1 to means V1, V2, V3, V4, till V4, you will be seeing vias here in this place only. Okay. Means vias will be placed on one. Okay. Means in a stack. So this is called stacked via, means placing more vias in a same place to connect the thing. From M1 to M5, you no need of any extra metals. Through vias you can connect. Okay.
Okay. We have to use this for 5 vias, sir, for M1 to M5.
That's it. 4 vias. V1, V2, V3, V4.
Okay, sir.
See here. Every time just remember this pattern. First metal 1, then metal 2. Okay. In between via 1 means via 1 contains properties of M1 and M2. Okay.
Yes.
So only V1 can connect M1 and M2. If you have M1 and M5, if you are using a V1, it's not possible because V1 is for either to
M1
deal with M1 or M2. That's it. Okay.
Yes.
So again, M2 to M3, only V2.
Okay.
The same way. So if you put all these V1, V2, V3, V4, V5, no need of this metal one, I mean M2, M3, M4, M5, right? So you have
Yes, sir.
M1 here and M5 here. You are putting lots of wires, means V1 to V4, because till M5, right? I told. So M5
Yes,
you
sir.
already reached it through the V4. So no need of V5. V5 means M5 to M6. V5, right?
Yes, sir.
No need, you don't need any M6, right? You need only till M5. So V4 is fine, right? So V1, V2, V3, V4.
Yes.
That's it. So you are placing wires one on one. Okay, this is called stacked wire. Okay,
Yes, sir. Understand.
that's it. Let's move to the next file. Yeah, this is what about def. Okay, design exchange format. And let's see the input creation for ICC. Input creation for ICC means fine. So to create Milky Way library, we already discussed about the Milky Way. See, 1 second. ICC, MWlib, fp.db, placement.db, cts.db, routing.db. Floor plan, placement, CTS, routing. Floor plan, placement, CTS, routing. What we have missed? Floor plan, power plan, placement, CTS, routing. Okay, fine. Floor plan and power plan will be having the same. Okay. So these are like database. These will be with the format of .db. Okay. This floor plan .db is enough to check entire floor plan database. Okay. What every single clue you can load this floor plan database and you can get the thing. Okay. So by combination of all these database, you will be getting MWlib, means Milky Way library. Okay, in this library you have all the database. Okay, for example, you have Milky Way library. Now you renamed, I mean, now you want to do one more experiment. Now you created one more thing like MWlib _ exp1. First experiments you are doing. Again you started floor plan, power plan, placement, CTS and routing. For example, you want to do from the CTS only. Then you need to copy from the floor plan to placement. Okay, fp.db plus power plan placement.db till this placement.db you need to copy. Then you can start the CTS, because without having the prior stage you can't start the next stage. Okay, so whatever I mean, what I'm trying to tell is like you have the good results till placement, but you are getting some CTS bad results. Okay, now what you have to do is like copy till placement database. Okay, placement.db in this thing, and made the respective changes. What are the experiment you are trying to perform? Means changing some kind of skew differences or something. Some experiments you need to change. Okay, so till placement you are okay. Now you want to change that. You want to make the changes with respect to the CTS stage. So you made some changes with respect to the CTS settings. Okay, in the CTS block setup file will be there. Okay, means some of the clients will be using block setup. Some of the files will be like some pre-hook, post-hook files. Means some extra changes, manual changes. What are you going to perform? Okay, those will be called as pre-hook or post-hook files. Okay, hook files. Okay, so till placement you are okay. From the CTS you want to do some changes. So you need to copy floor plan and power plan placements DBS here and start the CTS from here. Means this is like Milky Way library with experiment 1. Okay, you did some you got CTS also better way. Now you need to create one more experiment for routing stage only. Now you copy from floor plan to CTS and paste it into the MWlib _ exp2. In this experiment you are pasting all these things, and now you are starting the route database by doing some necessary changes. Means my Milky Way library consists of all the database. Okay, combination of database, we call it as Milky Way. Okay, got the thing what I'm trying to tell? So let's see how to create a Milky Way library. Usually we don't create Milky Way library. I mean, if we run one PD flow, obviously our Milky Way will be created. but this is like a basic way how to create. Just I'm trying to tell these things for a knowledge purpose. That's it. Okay. Manually, we won't create any Milky Way library. Okay. If we run a PD flow under Milky Way library, floor plan DB will be formed. Then placement CTS routing. Whatever the stage you gets completed, everything will be under Milky Way library only. So you are not creating any manual way. Okay. This is like kind of full chip level people are. This is like some test chips will be there. There you won't be seeing any flow. Okay, no flow would be there. There you need to do this thing. These are not like these are like 10% chance in the out of 100. You need to perform all these things. Okay, so to perform all these things, also you will be getting the comments in your files. Okay, I'm just sharing these things for a knowledge purpose. Okay, just try to understand the things. So create mwlib is the command to create one more Milky Way library. Okay, under this mwlib, what are the things you have? What are the things you are going to get the list, floor plan, power plan, placement, CTS, all the DBs, database. Okay, so under this Milky Way library. Okay, so import design.v hyphen format Verilog means I want to create one Milky Way library with the help of netlist. Which netlist? Design.v hyphen format Verilog. Okay, means I am just collaborating all the inputs to create a Milky Way library. Okay, so to create a library, I'm just first getting the Verilog files. Okay, so read def hyphen for scaling allow physical objects design.def optional. If you don't have def, we need to create one using create floor plan command. These are not like really these are not for a block level or a fresher level, but I'm just sharing the thing. So as I said, if you are doing your floor plan, you won't be getting any def. Okay, if you are working as a block level owner or partition level owner, you will be getting def file, .def file from your subsystem or full chip level. Okay, yeah, this is the thing what I'm trying to tell. If we don't have def, we need to create one using create floor plan command. Okay, so if you create one, if you create one floor plan, the output will be like floor plan.def, right? Floor plan.def, floor plan.db, both are different. Okay, so whatever the changes you did, okay, so after all the thing, and if you get the perfect database for the with respect to the floor plan, you will save into floor plan.db, means that is the final version of floor plan. Floor plan.def is like just in the floor plan, if you have any pre-routes from where it is getting started, where your macros are there, where your stand cells are there, if you are placing any stand cells. Okay, this is called def. The final, the perfect stage of floor plan is called floor plan database. Okay, see, you can have multiple floor plan defs. Okay, you moved one macro. Let me write that. See, for example, you have one macro here, you have one macro here, you have RAMs here, for example. Okay, you have some more macros here, and you have blockage here and blockage here. Okay, now if you want to dumb down, this is called one floor plan def. Means it will be telling here I have one macro, here I have one blockage, macro, and blockage. This is only floor plan def. Okay, then you will be asked to change some more things, means add some more macros or change the place of a macro. Now you created and you just increase the distance between these two. Now you will dumb down the floor plan.def. Okay, this is called floor plan.def1. For example, this is like floor plan def2. You can do n number of defs. What are the changes you do? You're just saving like floor plan.def, but the entire changes will be saved and will be saved in the final version, will be floor plan database. Okay, that is the thing. For example, yeah, I can tell you one thing. See, this is like just an example. Okay, real time example. For example, you have some AND gate.v, OR gate.v. Okay, for example, somehow you made 2 input AND gate. Your lead asked you to make 3 input AND gate. Now you modified. Okay, this is floor plan.def. Okay, now you gave all these things I mean, you say you did all the respective changes and you gave, and I converted into .vg. Means I did my own thing. Okay, I created one output. Okay, this is called .db. Means the final output. Whatever the changes you did, I'll get the final version. Is called .db. Whatever the single change you means, you have 2 input AND gate also, 3 input AND gate also. 2 input AND gate is like AND gate .def underscore 2 input. What are the name you can give? AND gate underscore def underscore 3 input. This is one def, this is one def. But the end, okay, for example, you have only 2 input AND gate. You saved the thing. This is called .database. Now you only ask to create one more 3 input AND gate. You created 3 input AND gate instead of this. Okay, you just remove 2 input AND gate, you modified into 3 input AND gate, and you saved again all these things. This is called .db. Okay, .db is different, .def is different. Okay, got the thing what I'm trying to tell everybody?
Yes, sir.
Cool.
Yes, sir.
Yeah, that's the thing. So why we got stopped here? Yeah, if you don't have def, we need to create one using create floor plan. Means you're just creating one floor plan and you're creating one def. Okay, the thing is like you're giving the def, you're giving the Verilog, you're giving, I mean, you're collaborating all the inputs. Okay, to create one Milky Way library. Okay, that's the thing. Okay, so this is like set search path. This is like very important and tricky part. Let me tell you. As I said, right, I think you remember my words. As I said, until unless, okay, you give the external .lib or physical or logical libraries, whatever the thing you give, okay, usually from the bunch of, I means .lib means -max lib, -min lib, -nominal lib kind of, we'll be having more number of some n number of libs, as I said, right? Until unless you are doing some manual changes, okay, these libs will be being read by the tool itself. I told, right? The tool will read all these things. Okay, .lib where the max lib is there, the tool will be there, or you'll be getting some source files. Okay, the chip level or subsystem level people will be giving the cheat sheet file. Then you will be putting some. This is where you need to read. You are telling the tool. Okay, somehow you need to make some changes. Okay, now you need to add one more stuff. For example, in that file, for example, you want to add one more thing is like you want one more corner. For example, example corner you want. This is like example only. Just don't take this thing. Okay. So why I am telling this thing is like, see here, set search path. Okay. How we are going to set the search path? I am trying to explain. Okay. So for that thing, you are creating one kind of example corner. Okay. So example corner in max, in very high temperature, this much delay, in very low temperature, this much delay, in nominal temperature, this much delay. You created one example corner, for example. Okay. So now you created this manually. You didn't get this thing for your user convenience or for some experiment purpose. You want to create this thing. Okay. Then you want to tell to look into this particular file, and you saved this like example underscore corner, some file name you saved. Okay, example underscore corner with the file name you saved. Now you have to tell your ICC tool, read this file as well, create this scenario as well. Okay, then how can you tell? The thing is like, see, and along with the remaining corners, you have created this corner and placed it along with the corners. Means some .lib file underscore max, I mean under max and nominal temperature. Here you have all the libraries. Now you have copied this example underscore corner as well. Okay, so what is the real path of this? Kind of some okay, this is how your real-time path will be like. Means the original path I already told, right? Absolute path, if you remember in the Linux path, If you give absolute path or real path, okay, if you give real path or absolute path, okay, then you will be getting the full path. Okay, you can access the full path if you have permission. Okay, so this is where, see, if you want to tell your tool to search one particular path, okay, means you have corners here. Till max you need to tell the tool. Okay, for max you need to search inside the max, you want to tell, but at this point of time you will be giving like set underscore search underscore path, set underscore search underscore path. Okay, you will be giving this particular path. Okay, means whenever you want to give a manual path, this is how you are going to set search path. Sorry, not set underscore, set one second. Set search underscore path means you are telling your tool to search in this path, means search path you are telling something. Okay, for example, set search path, this particular entire path you will be giving in one particular file. Okay, now you are sourcing, means wherever the file will be looking for a search path, obviously this file will be sourced. Okay, means you're setting, means you're telling the tool, okay, search in this path. What is the path? This entire path. Okay, this is what set search path, and the path which you are, means any libraries are given without complete path. Okay, means if you want to give any particular, see, up to max if you want to give, you can give. Here we have nominal temperature, max temperature, minimum temperature. Okay, so up to max if you want to give, okay, in this path search, okay, means search till the max, then you will be getting multiple corners. Okay, what are the corner you want, you can take. In this way you are going to tell your tool, okay, ICC tool. Okay, let me minimize this thing. If you want to give any additional path, you need to tell the tool look in, I mean search in this particular path also. Then you will be giving set search underscore path, this particular entire path. Then tool will be searching for this particular path and using the libraries or corners, what other thing. Okay, this is what set search path. Okay, set link library. Okay, see, when linking libraries, we will check the libraries from this variable starting from the first name in the list. Means let me minimize the thing. In the same thing, underscore minimal here, some .lib file is there, for example. Okay, .lib file is there, some abc.lib, your file name is, okay, underscore .lib max nominal temperature, you have abc.lib file. Okay, so if you want to put like, I mean whenever tool needs to look for some a link library, means in this library, in this abc.library, you have all the content about this example corner. Okay, so now you are telling the thing like set space link underscore library. Okay, here you want to give the this particular library, means see, in the search path it will be coming here. Now you are telling set link library. In this nominal, what is the library you want to select? abc.library. Now you will be giving this thing set space link underscore library, some abc.lib. Now it will search till the nominal corner, then it will link the abc.library. Okay, this is the thing, means we are collaborating all the inputs. Now you created the mwlib, now you collaborate all the verilog files, now you created one def and gave the thing. Now you are searching the libraries, where you are telling the tool where to search the libraries. Okay, now you are telling where to pick the libraries. Okay, now set target library. Okay, when compiling the design, target library is used. Okay, in the same way, link the library or target library means by using this particular library you give the particular output. Okay, and under this .lib file, if you have some any another thing, this is the target library. That's way. Okay, this is like just collaborating, I mean to tell the tool to check this particular thing. Okay, the simple thing. Okay, don't be confused. Okay, these are not really required for you people, just sharing for the knowledge purpose. Okay, so scenario creation, These are like very much these are for very advanced people. For fresher people, these are not required. Scenario creation, operating conditions. Abba. Fine. I'll tell you anyway. Why to skip these things. Yeah, we're discussing this thing, right? So scenario creation. I already told, right? Scenario is combination of operating condition and RC corner. Okay. Means for this particular condition, means for this particular temperature, for this particular voltage, for this particular process, what is the delay? Okay. By combining all these things, you are going to create one scenario. Okay. Funcmax high VCC XLT is one scenario. Okay. Max is one corner, min is one corner. Funcmax high VCC XLT is one scenario. Okay, the same thing. So to create one, these are like very, these are needed for advanced people, and that too full chip level or subsystem level people, these are really required. We don't create any scenarios in our own. We'll be getting these files, but just for knowledge sharing, I'm just sharing, but I really don't want to talk about these things. These are like very hectic and very pro level concept. These are like, fine, whatever. So if you want to create one scenario, create underscore scenario, whatever the scenario you want to create. Example underscore scenario you can give. Okay. All the commands given under this command will belong to this scenario now only. Means now you are creating one scenario. So whatever the thing you are going to perform, it will be affecting, it will be being added towards this scenario only. Okay. Set TLU plus files -max TLU plus the file path -tech to ITF map the map file. Okay, all these things you are going to include. Okay, means you are giving the required inputs to create one scenario. Okay, map file to map the layer and via names of TLU plus file with the Milky Way tech file. This is like what the really map file and the TLU plus file will be containing, and how to map the thing. That is the thing about. So set extraction temperature -max value -min value. Means in this scenario, what is the maximum temperature you want? What is the minimum temperature you want? What is the clock uncertainty you want? Okay, for setup or hold, what is the value? What is the SDC you want to give? Means you are creating your own scenario. Now you need to give all your own values to do one experiment, right? See, D-rate values, -min, -late, what is the value? -max, -early, what is the value? -max, -late, what is the value? The same thing, okay? Timing D-rate can be set on either net or cells or both. Okay, means whatever the thing. Apply timing D-rate. We have already seen the along with the timing D-rate one. We have seen one timing report, right? You can apply timing D-rate either on a net or either on a cell. Completely depend. Same only. Why? Because if you apply on particular cell, okay, the cell delay plus timing delay plus that particular net value is called one delay, right? One particular delay value, right? The same thing. If you applied on the output net or if you applied in the input cell, both are same only, right? It really doesn't make any changes. So operating conditions. See, the following example shows an operating condition definition as it appears in the source text of library. Okay. See, for example, you created one operating condition like BC COM, means best case COM. I really don't know what is BC COM. For example, this is the operating condition you want to create, for example. Okay, so process is like 0.6 means 0.6. For every process, one number notation will be there. Okay, for this particular process, this is the number. Okay, if you are, this is the way you tell. I'm using this process. Which process? Just remember, by using this particular number. This is how we are going to tell the tool. Okay, the process number is like 0.6 and temperature is like 20 and voltage is like 5.25 volts. Tree type is like best case tree. Okay, means what are the thing? Here you are talking about everything is like best only. Okay, less delay. Okay, less timing, less power wastage, everything best only. Okay, no temperature at all. Helping temperature and all. Okay, see, process. A floating point number that represents the characteristics of a semiconductor manufacturing process means this thing. See, process means one number will be indicating. This particular number 0.6 means one particular process will be mentioned. Okay, the same thing. For temperature, one floating number. For voltage, one floating number. Okay, the same thing. Tree type. The interconnect model of environment means how the connection was there. Means the CTS stage or what are the thing. The clock tree we're going to build, how the interconnection was there, everything. Okay, the tree type we're going to. 3 models are available, which are like best case tree, worst case tree, and balanced tree. Means best case tree means which assumes the net delay to be 0. Usually it is not at all possible. Means you won't be seeing any net delay as 0, right? Obviously you'll be seeing one net delay. Whatever the thing, either it is like at least 0.001, you won't be getting any 0. Means this is like an ideal case. So worst case, which uses the lumped RC model, means the worst case. Okay, balanced tree means the average one. Okay, not really worst, not really best, kind of average. Okay, see how to set all these things. Set operating conditions, operating condition name hyphen library, which of the library you want to give. Okay, to get operating conditions from it. Okay, this is the thing. So tool gets the operating conditions from the library and finds the libraries with the similar operating conditions to use for the timing analysis. This is the thing I told you. See, you gave one search path, right? Set search path. In that search path, you gave one target library, you gave one link library, right? In that particular, see, tool gets the operating conditions from the library, means here till this point it is searching for the particular search path. Set search path you gave, right? So in the search path it is there, and finds the libraries with the similar operating conditions to use for the timing analysis. Okay, some respective whatever the things are really sync in with the particular operating condition. These are like very back-end process. We don't do all these things, but just for as I have the information to teach you, I'm just giving the information, but these are not really needed. Okay, just for knowledge sharing, that's it. Okay, don't worry about all these things. We don't create any scenario, we don't create any Milky Way library. If you perform your PD activity, obviously your Milky Way library will be created. Okay, you won't be selecting the target library, you won't be creating a particular operating condition and selecting all these. These are like for full chip level people, all the STA people, these are really required. Okay, don't worry about all this. That's why even I'm not giving much importance for all these things. Okay, in my entire experience, I never created any scenario because this is like a back-end process. Some other team will be working for all these scenarios and all. Some STA people are full chip level people. Okay, don't worry about all these things. So initial checks. So what are the initial checks we are going to perform before doing our PD activity? Before starting our PD activity, what are the initial checks we are going to perform? Let's see the thing. Okay. Fine. Okay. We'll see these initial checks. What are the checks? Means here we are collaborating all the inputs. Okay, now you are about to start your PD activity. Okay, so before starting your PD activity, what are the checks you need to perform? Then if you get all the checks passed, then you will start your PD activity. Means you're going to start your input design and floor plan and power plan placement, series routing and all. Okay, so before starting your PD activity, entire PD activity, what are the initial checks? If you get all these checks passed, then you will start the PD activity. Okay, so what are the checks we have? Okay, so we'll see all these checks and what we're going to perform in the next class. So that's it for today's class, and if you have any queries, please let me know. Anybody?
No doubt, sir.
Cool. One more time, I'm repeating, don't worry about the scenario creation and all. These are not really needed. These are not really in our hands. I never created any
Hello,
scenario.
sir.
Okay, don't worry. Yeah, Nagendra.
Yes, sir. Can we expect interview questions as inputs of the
No, man,
physical
really.
design activities?
No, not at all. What is scenario?
Okay.
You will be getting this question. How to create scenario? What are the things included in the scenario? Nobody will ask. Okay.
Okay.
I can give assurance. No issue at all. Because I know, right? I mean, I do take interviews. How a fresher people will be thinking like, and what could
Even,
be the
even if they will ask also, what is the scenario means we can explain, sir. We can easily explain. So it
Sorry?
includes the library files or PingDef files.
That's it. Means,
Yeah, even we can answer that.
yeah, understood. For a scenario, what are the operating conditions you have? What are the, you think? Means you are creating an
Yeah.
example scenario. For this particular scenario, what is the
Yes.
maximum temperature you want? What is the minimum temperature? What is the minimum delay you are expecting? What is the clock
What are the
uncertainty you are
parameters
expecting?
included in
Yeah,
that?
that's it. Okay.
While
Don't worry
giving
about
the
all.
answer, we can include all the parameters what are
That's
the
it,
existing in
that's
that scenario.
Usually
Yeah.
99.999% nobody will ask these things. Scenario creation and all. I don't know why these things were attached for a fresher level, but it's my duty to teach all this. That's why I'm just telling. Okay. Don't worry about all this.
Yes, sir.
So anything else? Any queries? Any doubts?
No, sir. The tool is not working actually.
Still?
Yes, sir.
Okay. By the time we enter into the floor plan, I will get the thing done. Okay. I mean, at least I will
Okay.
I will try to make it ready. Okay. I mean, I will ask them to make it ready.
Oh,
Yeah, don't
okay,
worry.
sir. Okay,
Yeah,
sir.
we are going to perform floor plan and all together. Then you're going to see the
Yeah.
real-time things. Okay. No need to worry.
Oh, okay, sir.
Cool, man. Yeah, that's all from my side, guys. So let's wind up the session if you don't have any doubts. And if you have any, please be
Okay.
here. If not, please move on.
Okay, sir.
Cool.
Good night, sir.
Yeah,
Thank
good night, man. Yeah, bye.
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 Bye, sir.
Yeah, bye.